Hello everyone, welcome to Chapter 2. In Chapter 2 we're going to talk about elements. And a lot of elements you've probably heard of, and so I'm going to talk about some at the end of this section to remind you of that. So an element is what we call a pure substance, so that means it can't be broken down into anything smaller chemically. Each element is going to be identified by either one or a two-letter abbreviation, and there are several of these. We actually have a periodic table of the elements that shows us all of these. Okay, and so in some of the next chapters, we're going to actually see that and see how that they are actually put together. And so the way the periodic table is set up is that you can actually see things that are similar. Okay, so they have similar properties. So here's just some examples. So notice that carbon is just the letter C. So that one makes a lot of sense. Chromium, chlorine, fluorine, iodine, hydrogen. All of these make a lot of sense. Nitrogen, oxygen. But then you have these crazy ones. Potassium is a capital K, and sodium is a Na. So there are some that have sort of unusual abbreviations that you may need to commit to memory. So this is what the periodic table looks like. And as I said, we classify these in groups and periods, they're called. And so like everything, sorry about that, touch the screen. Everything that's in this column will have similar properties. Everything in the same row will change properties in a periodic pattern. So the elements in the periodic table are divided into three major categories: metals, nonmetals, and metalloids. Metals are on the left-hand side, okay, and they're good conductors of heat and electricity. Nonmetals are on the far right-hand side, and they do not conduct electricity very well. Okay, and metalloids are actually between the two, so they have properties of both. So boron, silicon, germanium, arsenic, antimony, tellurium, and astatine are all your metalloids. Now let me show you on this periodic table. There's a jagged line here on all periodic tables. Okay, and so this jagged line, if it touches it, everything that touches it is in yellow here, is going to be a metalloid. The only two touching the line that aren't are aluminum and polonium, and so I say alpo are the only ones touching the line that aren't the metalloids. It's just kind of the way I remember it. So elements are the building blocks of the body and everything really. The four elements in the body, however, are 96% of the mass of the body: oxygen, carbon, hydrogen, and nitrogen. All of those nice, easy ones. So CHON are the ones in our body. Carbon, hydrogen, oxygen are found in our biological molecules: proteins, carbohydrates, lipids, nucleic acids that make up DNA and RNA. Okay, the proteins and nucleic acids also contain the nitrogen, so that's why we need all of those different elements so that we can make new biological molecules in the body. Major minerals are present in small amounts in the body, about 100 milligrams each. Magnesium and sulfur, for example. Trace elements, however, are the small quantities, very, very small quantities, like 15 milligrams of each of these. And these are requirements. So those major minerals, the 100 milligrams, and the trace, we need to have those amounts. And so that's what we call vitamins when we take those. Iodine is something that we really need, because if you don't have enough iodine, you're going to have what's called a goiter in your neck, and that's this big thing that's associated with your thyroid gland. So you have these building block elements such as carbon, hydrogen, oxygen, and nitrogen. And then you have all these trace and very small quantities, some of them. But if you don't have it, then you can't make some of the enzymes and things like that are very important in the body. These major minerals, though, if you don't have those, you're in serious trouble. The potassium, the sodium, even the chloride, magnesium and sulfur, and calcium. Okay, these are need calcium and phosphorus, for example, are needed not only for bones and teeth, but also so your heart beats. Okay, if you got too much potassium and too little sodium, or vice versa, then you can have problems with your health. So those major minerals are very, very important. So these elements will combine together, and two or more of them get together and they form what we call a compound. Okay, and so when we have a compound like that, what we want to do is we want to show people, okay, I'm talking about water, or I'm talking about propane, or whatever. Okay, so I need a chemical formula, which is a shorthand way of showing you that. So I use the element symbols in order to do that, to show people what is in a particular compound. So I use subscripts to show how many of each, or the ratio. So for example, water, we write water like H2O, right? It's really HOH. So I have two H's and one O. So having that subscript there of the two tells you that for every oxygen you have two hydrogens. This is the symbol for propane. Okay, so when we have propane, we have 3 carbons and 8 hydrogens that are going to come together and form the compound called propane. So when we write compounds, we're going to always tell you how many of each thing we have. So one way of doing it is the formula like we just looked at, and we're going to look at water as an example. But there are lots of ways that you can do these. This is called a ball and stick method because it's like a ball with sticks. But it gives you more of a three-dimensional look at what those are. And then you'll also see what we call space filling models. Space filling tries to more show you spatially in 3 dimensions what that would look like. Often in these ball and stick molecules, or in the space filling molecules, you'll see them designated as different colors. Carbon's almost always black, hydrogen's white, and then oxygen's red. And then depending on your book, you may have different ones. Our book uses this particular color scheme though. So if you see molecules that are put together like that, you're going to see those with those different colors. And that's the end of 2.1, and I hope that you have stayed with me and that you'll come back with me, and we will meet again.